After analyzing source code manually, automated tools allow the tester to focus on the more complicated business logic for efficient static analysis. There are several open source tools for automated security analysis of an APK. We'll use Mob SF for this purpose. So Mob SF is a powerful security assessment framework. It's capable of performing static and dynamic analysis. So why don't we get started? All right, so just open up a terminal screen and switch the user to root. Change directory to Mob SF folder. List files. Okay, so now we need to run the run.sh file. And it's running at this address now, so let's open it. Click on the button, Upload and Analyze. Select the APK file and open it. So right now it's analyzing the APK file. We can look at the info messages on the terminal screen. And these are the steps that we follow while manually analyzing the source code. So first it unzips the APK file, and it then reads the Android manifest file, checking the code signing certificate, decompiling to Java source code. So it may take a moment or two. All right, so it's completed. Let's have a look at the results. So in the first section, there's information about the APK file. Some of them are file names and sizes, Android version, package name, main activity, etc. From the decompiled code section, you can download any file and code format. So when we decompile the APK file with the bytecode viewer, there was no smiley code. So we'll first look at the Android manifest file. As you can see, it's in the decoded form. So we'll go back. Click on View Source. And we can search for basically any keyword in the source code. So why don't we just search for password? And we can see the Java files that contain the password. Let's open one of them. Scroll down a bit. And here's where you can see a method where the password string is defined. Right, so we'll go back to the scan results. Let's look at the smiley code. Search for password again. Oh, you know what? This error here is due to Mob SF, but right now this error is not really important. So you can view the smiley code by downloading it as a zip file. And you can download the source code here. So let's continue with the titles. So in the signer certificate, we can check if the APK is signed or not and what the signature algorithm is, hash algorithms are, and more. And as you can see in this description, the application is vulnerable to Janus vulnerability because of the signature scheme. So why don't we have a look at the permissions? Now you remember we saw these permissions in the Android manifest file, and this table will show us the status and the risks of them. And we'll go to the next one. So there's no result for binary analysis, API, and browsable activities. So let's look at the analysis of the manifest file. And yeah, again, as we saw in the manual analysis, there are dangerous options in the manifest file. Debuggable, allow backup options, and exported activities that are shared with other apps. Let's continue. There's no result for code and file analysis. So let's go to malware analysis. APK ID gives you information about how an APK was made. So I can look at an Android APK or DEX file and detect the fingerprints of several different compilers. All right, good. Let's continue. So there's no information for these sections. These are trackers in the application. They can collect a range of data from the user, including users' keystrokes, location, web browsing, personal data. And here there's a strings list under the reconnaissance section of the result. So let's look at the hard-coded secrets. These are the fields where it's possible to find hard-coded values. Under the components section, you can view the lists containing application components such as activities, services, receivers, providers, libraries, etc. And you can also export the scan results that have the PDF format from here. Let's download the report. That way we can look at the results later when we need to. Save file, okay.